Assalamualaikum to Dr. Zamir and my fellow friends. My name is Farah Diana binti Ramzi and my metric number is 138923. In this video, I will present about MOSFET. MOSFET is a metal oxide semiconductor field effect transistor with an insulated gate where the voltage will determine the conductivity of the device, and it is widely used for switching and amplifying electronic signal in the electronic device. It also called as insulated gate field effect transistor. MOSFET is the most common transistor compared to BJT, bipolar junction transistor, and it can be used in both circuit, analog and digital circuit. MOSFET has three-layer structure of P and N-type semiconductor. As we can see from this figure, firstly we start with high resistivity P-type substrate, and then two heavy dose of N-type material are diffused into the substrate, and the surface are coated with the silicon dioxide. And then the holes are cut through the silicon dioxide to make contact with N-type material. And then the metal is deposited for the drain and source terminal. And between the drain and source terminal, there will be a metal plate are deposited on the surface. MOSFET is a four-terminal device with source, gate, drain, and body terminal. So the body always connected to the source terminal and making it a three-terminal device like field effect transistor. Since they can be made either P-type or N-type semiconductor, it is complementary pair of MOS transistor that can be used to meet switching circuit with a very low power consumption in the form of the complementary metal oxide semiconductor CMOS logic. One of the key parameters is the channel length, which is the distance between two M plus and P junction. This one is L. And when the first MOSFET was developed in 1960, the channel length was longer than 20 micrometer. And today, channel length less than 1 micrometer has been fabricated in volume production. And length less than 0.1 micrometer has been created in research laboratories. The working principle of MOSFET depends on the metal oxide semiconductor capacitor. The MOS capacitor is the main part. The semiconductor surface at the below the oxide layer and between the drain and the source terminal can be inverted from P-type to N-type by applying a positive or a negative gate voltage respectively. When we apply positive gate voltage, the hole present under the oxide layer experiences the repulsive force. The holes are pushed downward with the substrate, and the depletion region is populated by the bound negative charges, which are associated with the acceptor atom. The positive voltage also attracts electrons from the N plus source and the drain region into the channel. The electron reach the channel is formed. Now, if a voltage is applied between the source and the drain, the electric current flows freely between the source, and drain gate voltage control the electron concentration of the channel. Instead of positive, if we apply the negative voltage, a whole channel will be formed under the oxide layer. MOSFET can function in two ways, enhanced mode and depletion mode. Under enhanced mode, there will be P channel and N channel. Same goes to depletion mode, there will be P channel and N channel. Enhanced mode, when there is no voltage on the gate, the device does not conduct. The more voltage on the gate, the better the device can conduct. While the depletion mode, when there is no voltage on the gate, the channel shows its maximum conductance. As the voltage on the gate is either positive or negative, the channel conductivity decreases. The four MOSFET symbol shows an additional terminal called substrate, as you can see from this 1, 2, 3, 4. And is not normally used as either an input or an output connection, but instead is used for grounding the substrate. It connects to the main semiconductive channel through a diode junction to the body metal or a metal tap of the MOSFET. Usually, in discrete type of MOSFET, this substrate list is connected internally to the source terminal. The line in the MOSFET symbol between the drain and the source terminal represents the transistor semiconductor channel. If this channel line is a solid unbroken line like this, unbroken, and this one is unbroken, it represents a depletion type MOSFET, as a drain current can flow with zero gate biasing potential. If the channel line is shown as a dotted or broken line like this one and this one, indicate an enhancement type MOSFET as a zero drain current flow with zero gate potential. The direction of the arrow pointing to the channel line like this one inward, this one outward, indicate whether the conductive channel is a P-type or N-type semiconductor device. The enhancement and depletion type MOSFET use an electrical field produced by a gate voltage to alter the flow of a charge carrier, electron for N channel or hole for P channel, through this semiconductive drain source channel. The gate electrode is placed onto a very thin insulating layer, and there are a pair of small N-type regions just under the drain and the source electrode. With an insulated gate MOSFET device, no such limitation applies, so it is possible to bias the gate of a MOSFET in either polarity, positive or negative. This made the MOSFET device especially valuable as electronic switches or to make logic gates because with no bias they are normally non-conductive, and this high gate input resistance means they are very light or no control current is needed as MOSFET are voltage control device. In N-channel MOSFET, a lightly doped P-type substrate is taken into two heavily doped of N-type regions are diffused, which act as source and drain. Between these two N-plus regions, this occurs diffusion to form a N-channel, a connected drain and source. A thin layer of silicon dioxide is grown over the entire surface and holes are made to draw ohmic contacts for the drain and the source terminal. A conducting layer of aluminum is laid over the entire channel upon the silicon dioxide layer from source to drain, which constitute the gate. This silicon dioxide substrate is connected to the common or ground terminal. If the NMOS has to be worked in depletion mode, the gate terminal should be at negative potential while drain terminal should be in positive potential. When no voltage is applied between gate and source, the current flow due to voltage between drain and source. If some negative voltage is applied at gate voltage, then the minority carrier holes get attracted and settle near silicon dioxide layer, but the majority carriers electron get repelled. With some amount of negative potential at gate voltage, a certain amount of drain current flows through source to drain. When this negative potential is further increases, the electron get depleted and the current decreases. Hence, the more negative the applied voltage, the lesser the value of drain current will be. The channel nearer to drain get more depleted at the source and the current flow decreases due to this effect. When this positive potential is further increased, the current increases due to the electron from the source and this further pushed due to voltage applied at gate voltage. Hence, the more positive the applied gate voltage, the more the value of drain current will be. The current flow get enhanced due to the increase of electron flow better than depletion mode. For P-channel MOSFET, a lightly doped N substrate is taken into which two heavily doped P plus regions are diffused. These two P plus regions act as a source and drain. A thin layer of silicon dioxide is grown over the surface. Holes are cut through this layer to make contact with P plus region. When the gate terminal is given a negative potential at gate voltage than the drain source voltage, then due to the P plus region present, the whole current is increased through the diffused P channel and the PMOS work as in enhancement mode. When the gate terminal is given a positive potential at gate voltage than the drain source voltage, then due to the repulsion, the depletion occurs due to which the flow of the current reduces, and PMOS works in depletion mode. For drain current versus drain source voltage shows when voltage is increased, the drain current should be increased, but due to the applied voltage, the drain current is controlled at certain level, hence the gate current controls the output a drain current. So here drain current versus gate bias graph for all type of the MOSFET. There are a lot of applications of MOSFETs. Here I just list it of them. I will explain a little bit about MOSFET used as a switch. MOSFET used as a switch in the circuit arrangement. An enhanced mode and N-channel MOSFET is being used to switch a sample lamp on and off. The positive gate voltage is applied to the base of the transistor and the lamp is on, or at a zero voltage level, the device turns off. Intensity control of street light using MOSFET. This project is designed to control the light automatically on the highways using microprocessor by variants of the clock pulses. In this project, MOSFET plays a major role that is used to switch the lamp as per the requirement. Okay, that's all. Thank you.